Hello everybody, and once again welcome to Pankaj's Echelon tutorials for IGCSE 10th grade. As you can see on the screen, we are going to start with the subject chemistry, and the topic for today is organic chemistry part 1. Now this happens to be chapter number 12, I suppose, okay, from the 4th edition book, right? So this particular topic, organic chemistry 1, and then you have organic chemistry 2 as well, which will be followed by this organic chemistry 1. So in organic chemistry, what all things we are going to study, so that we are going to discuss first and get started with it. Okay, so once again welcome, and for chemistry subject, the topic that I've chosen is organic chemistry 1. So we are going to talk about organic chemistry. Now, chemistry as such is a very uh, large subject. Okay, it's a very vast subject. And in this organic chemistry, in this chemistry, you have various branches, like you have physical chemistry, you have something called analytical chemistry. Okay, you have organic chemistry, you have inorganic chemistry, and you have something called organic chemistry. Okay, organic chemistry. So today we are going to start with this organic chemistry, the branch of the chemistry which deals with the carbon compounds. Okay, so compounds of carbons or carbon compounds is nothing but organic chemistry, right? Now, where does the root of this organic chemistry lies, that we are going to discuss first. Okay, now all these carbon compounds, carbon is basically a main component of any living being. Okay, any living organism. So any living organism, say plant or animals, okay, when they die, okay, or when they decay, okay, after dying, these plants and animals, they get decayed. Okay, so when they decay, all the carbon substances or carbon compounds that is there in the plants and the animals, they start dissolving or they start mixing up with the soil. Okay, now in the very ancient period, millions of years ago, this plants and animals, when they used to die, okay, they used to not be disposed of like we do it today. Okay, so they used to just lie on the ground, and they used to decay and they used to decompose, and everything used to get mixed up with the soil, and ultimately it used to go into the earth, right? So all these carbon compounds present in the plant and the animal dead bodies, okay, used to go into the earth somehow. Okay, so inside the earth, what used to happen is this carbon compounds, which were the main constituent of the plants and the animals, that is the living organisms, these carbon compounds used to get mixed up, or it used to get settled inside the earth, and inside the earth is to get mixed up with the soil, and it used to go and settle in the rocks. Okay, and there it used to remain for millions of years, and under the pressure of the weight of the earth crust above this carbon compounds which is settled inside the earth, because of the pressure, because of the high temperature, that because of the water coming and getting mixed up with it. Okay, so there were so many things happening with it inside the earth. Okay, so after millions of years, what happened is these things, these carbon compounds, they got converted into something called crude oil. Okay, now crude oil is something which is rich in carbon compounds, and this crude oil, is formed or is present inside the earth. Okay, in the rocks and in the Earth's crust. Okay, so this crude oil is rich of carbon compounds, right? Now, this crude oil is something which is now being removed from the earth crust. Okay, it is taken out from the earth crust, and this crude oil is then processed, and it is undergoing certain chemical processes, mostly one of the process which is known as fractional distillation. Okay, so by going under that fractional distillation process, this crude oil, it is separated into various components that are contained in that crude oil. Okay, so crude oil is basically the origin of all the organic compounds, right? Now before we go into how this crude oil is removed from the earth and what is happening subsequent to that, okay, let us learn one more term which is known as hydrocarbons. Hydrocarbons. Now what are these hydrocarbons? Hydrocarbons are compounds of hydrogen and carbon only. Okay, these are known as hydrocarbons. Now crude oil is full of, okay, various types of these hydrocarbons. Okay, so these hydrocarbons, you know they can be of many types. They can be hydrocarbons of single bond, there can be hydrocarbons with double bond, there can be hydrocarbons with triple bond. Okay, so all this we are going to study in future. So hydrocarbons is the compounds of hydrogen and carbon, and these are the main constituent of the crude oil. Okay, so crude oil is made up of various types of hydrocarbons. Now, these hydrocarbons, it varies in the length of the carbon chain. Okay, so suppose you have a hydrocarbon which has two carbon chain. Okay, then you may have a hydrocarbon which has some four uh, carbon chain. Okay, there may be a carbon chain which is very long. Okay, so depending upon this chain, okay, this is known as the chain of the carbon compounds, right? Now in some you may find even double bond, in some you may find even triple bond. Okay, so these are nothing but the hydrocarbons. Okay, and along with this there will be some hydrogen also, right? So suppose this is CH. Okay, so 1 2. Okay, so CH2 something like that. Okay, so these are all known as hydrocarbons. Like, okay, you will have some uh, hydrogen also attached to this. Okay, so these are hydrocarbons, basically compounds of hydrogen and carbon only. Understood? Now what happens is these hydrocarbons, depending upon their chain length, okay, they can be divided into certain categories, right? So as I told you, this crude oil is something which is made up of all types of these hydrocarbons, and crude oil can be divided into many fractions. Okay, there's something called fractions of the crude oil. Okay, so if you take this crude oil and if you take it in a tower like thing, this is known as a fractionating column. Okay, or you can say a fractionating tower. Suppose this is a fractionating column, okay, or a tower. Now this fractionating column is heated from below. Okay, it is heated from below. Now in the fractionating column, when you put the crude oil, this lower layer, this lower fraction will be something which is made up of very uh, long chain hydrocarbons. Okay, so here in this region you will get long chain hydrocarbons, right? Hydrocarbons. Now above this fraction you have another fraction which is heavy fuel heavy fuel oil. Okay, this is another fraction, right? That way, this crude oil, when it is put in this fractionating column, and it is heated, this is the way the fractions of this crude oil are distributed in the tower. So the lowest part of the fractionating column will be occupied by the long chain hydrocarbons. Above that, you will find heavy fuel oil. Above heavy fuel oil, you will find diesel. Then above diesel, you will find kerosene. Okay, kerosene. Then you have petrol. Okay, and above the petrol, you have butane and uh, propane. Okay, all these are uh, totally in totality they are known as LPG, liquid petroleum gas. Okay, so these are the fractions. Okay, so this is fraction number 1, 2, 3, 4, 5, 6. These are the various fractions. Okay, so I've named them for you. These are the fractions, right? Now, as you go up, the hydrocarbon chain, the length of the hydrocarbon chain becomes shorter and shorter. So here on the top is propane and butane layer, Here you will find short chain hydrocarbons, okay? Short chain hydrocarbons, right? So that is all about this crude oil. And when this crude oil is heated, okay, all these components of this crude oil, it gets converted into vapors. Okay, it gets converted into gas, and this gas, these various fractions, they boil at different temperatures. Okay, so this may boil at a very high temperature, this may boil at a lower temperature, this may boil at a still lower temperature, that way. Okay, so all of these fractions, they are having different boiling points, and because of this different boiling point, what happens is the boiling of these fractions, takes place one by one according to the temperature which is reached. Okay, so the first one to boil will be the one which is having low boiling point. So this fraction number 6, this is going to boil first. Okay, because the components or the hydrocarbons in this layer, topmost layer, has a low boiling point. Okay, so this is going to boil first. It will get converted into vapor, and this vapor, will be collected and it will be condensed. Okay, it will be collected and condensed. Okay, and once it is condensed, okay, you can collect it in the liquid form, and that is how this condensed hydrocarbon is collected. So one by one, as the temperature rises, you will get a separation. You can separate these fractions also, and you can collect also the separate fractions from this hydrocarbon. So this is something which is done by a process called fractional distillation. Fractional distillation. So if somebody asks you what is fractional distillation, so fractional distillation is a process. This is a process uh, by which various fractions of the crude oil is separated and collected, making use of their varying boiling points. Varying boiling points. Is that clear? Okay. So that was about crude oil, and how crude oil is undergoing fractional distillation, and you can collect these various fractions, right? Now, a few more things let me tell you about this uh, crude oil. So crude oil, okay, is made up of, as I told you, short chain hydrocarbons as well as long chain hydrocarbons. Okay, now as you go from a short chain, say carbon carbon, to towards a long chain, okay, uh, say carbon 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 carbon, okay, n times. So this is a very long carbon chain. This is a short carbon chain. In between, you will have a medium carbon chain. Okay. So as the carbon chain, the length of the carbon chain increases, what happens is in this direction, the boiling point decreases. Okay. Sorry, the boiling point increases. Right. So what I mean to say is for the shorter length carbon chains, okay, the boiling point will be less. And for the longer chain carbon compounds, hydrocarbons, the boiling point will be more. So here the boiling point will be maximum. Here the boiling point will be minimum. Okay. So this is the way the boiling point increases from left to right. Now, there is something called flammability. Flammability, or you can say inflammability. Inflammability is a property by which a compound, gets burnt very easily. So how easily a compound can start burning, that is known as inflammability. Okay. So this inflammability is a property which will go on decreasing. Okay, so this property, I'll write this property as inflammability, IF. Okay, this decreases as you go from short carbon chain to long carbon chain. Okay, so flammability here will be maximum for the short carbon chain hydrocarbons, and here the inflammability T will be minimum. Okay, this is for the long chain carbon. So inflammability reduces as you go from short chain to the long chain. Is that clear? Then there's something called viscosity. Viscosity. Now this is a property which also, as you go from short chain to the high chain, it goes on increasing. So I'll write viscosity, it increases. Okay, so here the viscosity will be minimum. Here the viscosity will be maximum. Okay, viscosity means as you go from shorter chain to the longer chain, the compounds will become thicker and thicker. Okay, so that is viscosity. The viscosity increases as you go from short chain to long chain. Boiling point increases as you go from short chain to long chain. Inflammability decreases as you go from short chain to long chain. There's one more property that we should talk about, and that is what can we say is there's one more, which goes on decreasing when you go from this short chain to long chain. Let me check out so that I do not. Okay, flammability and contains plants, animals. Oh, okay, crude oil fraction. Okay, boiling point I talked about. Okay, flammability. There's one more. It's not coming to my mind immediately, but okay, once I recollect, I'll let you know. So these are the properties of these hydrocarbons, which, in this order, it will either increase or decrease as you go from shorter chain hydrocarbons to the longer chain hydrocarbons. Is that clear? Right. Now, fractional distillation is a process which will help you in, separating and isolating these fractions from the this thing. Okay, from the crude oil. Okay, fine. Now, the initial four, three, four, or you can say the initial short chain compounds, uh, they will have the nature. So I will write that also. So as you go from left to right, here they will be gaseous. They will be in the gaseous form. As you come here, it will be in the solid form. And in the middle, you will get it in the liquid form also. Okay. So the short chain hydrocarbons are mostly gaseous in nature, and as the chain length goes on increasing, they become liquid in nature. And when the chain length increases to a greater extent, it becomes solid. It becomes solid in nature. Okay, so this is also one of the trend that you will see as you go from short chain to long chain hydrocarbon. Okay, once this is done, now let us come to a topic which is something called the hydrocarbons hydrocarbons family. Okay, what is this hydrocarbons family? Right, now all these hydrocarbons, as I told you, hydrocarbons are compounds of hydrogen and carbon only. Okay, so these hydrocarbons, this can be classified, okay, or they can be divided into many categories, and the broader category is something called saturated hydrocarbons. I'm writing HC for hydrocarbons. Okay, and there's something called unsaturated hydrocarbons. Okay, you have many more, like you have ring compounds or ring hydrocarbons. Okay, or there's something called aromatic hydrocarbons. So these you are going to study in higher classes. For 10th grade, it is okay if you know that hydrocarbons can be divided into saturated hydrocarbons and unsaturated hydrocarbons. Okay, we'll be coming to this, what is saturated and what is unsaturated hydrocarbons, when we proceed. Okay, right now you try to understand that hydrocarbons can be classified into saturated, unsaturated. Okay, now hydrocarbons now can be divided into certain families. Okay, so again these hydrocarbons can be divided into certain families. Okay, now those families, let me name them. There's something called alkane family, there's something called alkyl family, there's something called alkene family, and there's something called alkyne family. Okay, so these hydrocarbons can be divided into these four families. Okay, now let us start understanding these families. Okay, so let us first talk about alkanes. What is this alkane? What are these alkanes? Okay, so alkanes, number one thing to note is it is ending with ane. It is ending with ane. Okay, another thing is it is mainly made up of single bonds only. Single bonds only. Okay, you will find only single bonds, right? And that's it. Okay, so alkane is always ending with the name is always ending with ane, and alkane is always having single bond. This is something you should know, should remember. Okay, now these alkanes, we are going to study first. Okay, the general formula, one more thing is general formula is CnH2n plus 2. This is the general formula of a alkane. So these are the three things you should know about a family. Okay, so alkane is a family whose names, the individual names, will be ending with ane. They will be having single bonds, and the general formula will be CnH2n plus 2. Fine. Chalo, let us start naming the family members. Okay. So very first family member, when you take n is equal to 1, that means carbon is 1. Okay. So you can write this as C1. And when n is 1, your carbon will be 1 and your hydrogen will be how much? It is 2n plus 2. So 2 into 1 is 2, 2 plus 2 is 4. So carbon, hydrogen will be 4. So you can write this as CH4. This is the first member. When n is equal to 1, this is the uh, compound that you get, CH4, and its name is methane, ending with a ane. Okay, methane, THANE. Right? Now, if you go down, when you take n equal to 2, it will become C2, and when N is 2, yeah, C will become 2 and H will become 2 2s are 4 plus 2, 6. So it will become H6. This particular compound, the second member of this alkane family, is known as ethane. Okay. Then if you go down, it will be C3 and then H8. This is propane. Okay. And if you go down C4, it will be H, 4 2s are 8, 8 plus 2, 10. So C4H10. This is known as butane. Now you'll see that all these names, of this individual alkane is ending with ane. The first one is methane, the second one is ethane, the third one is propane, the fourth one is butane. Okay, and as you go on, okay, you will get a list of this. You'll get a series of these elements, and let us go to 10. So C10, H will be 10 to the 20 plus 2, 22. This is known as docane. Okay. So this is something which is known as a family of alkane, or you can call it as homologous series of alkanes. This is known as homologous series of alkanes. Now, what is a homologous series? If you see these two consecutive members of this alkane family, methane and ethane, you will see there is a difference of this CH2. There is a difference of this CH2. Again, between ethane and propane, if you see, there will be a difference of this CH2 unit. Okay, so this CH2 unit is something which is separating the two subsequent members of the alkane homologous series. Okay, so homologous series of alkanes is a hydrocarbon uh, series with uh, uh, each member differing by CH2 unit. Okay, so then you'll find a CH2 difference between this CH4 and C2H6. You'll find CH2 difference between C2H6 and C3H8. Okay, so this is why it is known as a homologous series of alkanes. So I hope you must have understood what is a homologous series, what is hydrocarbons. These are the terms that now you should become very, very familiar with. Homologous series of alkanes, what are hydrocarbons, okay? And now, once you have understood what is homologous series of alkane, now in the similar ground or in the similar way, you can understand another families as well, okay? So now I'm going to write down only the family names, and I think you will understand the things. Okay, right. So these are the four different families of hydrocarbons. Okay, alkane, alkyl, alkene, and alkyne. Okay, this is ANE, this is YL, ending with ENE, and this is YNE. Right. Now, here the general formula is CnH2n plus 2. Here the general formula is CnH2n plus 1. Here the general formula is CnH2n. Now you will come to know all this thing very soon. And here the general formula is CnH2n minus a 2. Okay. These are the general formulas. Now going by these general formulas, okay, and the number, the homologous series will be, the first one will be uh, CH4, then C2H6, C3H8. See, I am increasing the number of carbon atoms by 1 and number of hydrogen atom by 2 as I go down this series. Okay, so methane mate is CH4, In ethane, it is C2H6. I have increased carbon by 1 and hydrogen by 2. Okay. Again, in the next one, I have increased the carbon by 1 to make it C3, and hydrogen I have increased by 2 to make it from 6 to 8. Okay. So that way I am getting a series of C4H10, then C5H12, then C6H14, then C7H16, C8H18, C9H20, and C10H22, and it goes on. Okay, this is the homologous series of alkane. Names: this will be methane, this will be ethane, this will be propane. Now remember this names with the carbon number. Okay, methane means 1 carbon atom, ethane means 2 carbon atom, propane is 3, butane is 4, then pentane is 5, hexane is 6, heptane is 7, octane is 8, nonane is 9 carbon atoms, and docane is 10 carbon atoms. Is that clear? Now, from this alkanes, from this homologous series of alkanes, if you remove one hydrogen atom, just one hydrogen atom, what will happen? Okay. So this methane, from this, if you remove one hydrogen atom, then it will become CH3. But when you remove one hydrogen atom, there will be one place vacant for some other atom to come in place of that hydrogen atom. So on removing one hydrogen atom from the alkane, what you get is known as the alkyl family. So this is known as, the name is written as methyl. Okay, here you have one carbon atom, so methane ka methyl. Now because it is alkyl family, it will end with YL. Okay, so it will, now you will call it as methyl. Same way C2, now from the C2H6, that is ethane, if you remove one hydrogen atom, it will become C2H5. But there will be one place vacant for some other element, some other atom of some other element to come and take the place of that hydrogen which is removed. Okay, so this is known as a ethyl group. Okay, or ethyl uh, uh, member. Okay, so that way you will get a series of members of this alkyl group. The general formula is CnH2n plus 1. What is the formula? CnH2n plus 1. Can you see here the N is 2. Okay, so it will become C2. And H will become what? 2 2s are 4 plus 1, that is 5. So C2H5. This will become C3H7. This will become C4H9. This will become C5H11. This will become C6H13. This will become C7H15. Okay, one hydrogen I am removing, C8H17, C9H19, and this is C10H21. This is a homologous series of alkyl. So this is another family of hydrocarbon. How to name it? Methyl, ethyl. This will be propyl or propyl, butyl or butyl. Okay, butyl, butyl. This will be pentyl. Now some say pentyl, some say pentyl. Okay, that doesn't make much difference as far as your spelling is correct. This is hexyl. It should end with a YL. This is heptyl. This is octyl, all ending with a YL. Nonyl, NONYL, and this is docyl, CYL. So this is that homologous series of alkyl. Next comes alkene. Now alkene is something which you get by removing Now this, here I'll write here 2 hydrogen atom from alkane. Okay, so alkene is a new group of hydrocarbons or a new family, and the names will be ending with ene. Okay, and this you will get by removing 2 hydrogen atoms from the carbon. Okay, now somehow this first place, you know, you cannot form any compound corresponding to methane. Okay, and the reason I'll tell you later. Okay, but the first methane does not have a corresponding alkene. Okay, but from ethane C2H5 or ethane C2H6, okay, from this ethane if you remove 2 hydrogen atoms, okay, what you will get? C2H4. Okay, this is a alkene. Okay, and because it is obtained from ethane, we will call this as ethene, ene. Okay, then same way from C3H8, that is propane, if you remove 2 hydrogen atom, it will become C3H6. Okay, this we will call as propene, ending with ene. Same way this will become C4H8, butene. Okay, then C5H10, this will become pentene, ene. C6H12, hexene, ending with ene. All these are alkene group. Okay, C7H14, heptene. C8H16, octene. C9H18 will be nonene, all ending with ene, and C10 and H20 will be dokene, ending with ene. So this is the homologous series of alkenes. Is that clear? So I have discussed homologous series of alkane, alkyl, alkene. The connection I have given: from alkane, if you remove 1 hydrogen, you get corresponding alkyl. From alkane, if you remove 2 hydrogen, you get corresponding alkene. And now coming to alkyne. Okay, alkyne family. The general formula is CnS2n minus 2, isn't it? CnS2n minus 2. Now, this family, how you are going to uh, name it? Okay, alkyne. Alkyne में alkyl is this. Okay, this is alkene, and alkyne में what should be done? From alkene, if you remove 2 hydrogen, okay, from alkene, if you remove 2 hydrogen from alkene, this was removing 2 hydrogen from alkane. This is you have to remove 2 hydrogen from alkene. Then you will get the corresponding alkyne. So again, here you won't get anything because here you don't have any alkene itself. Now from C2H4, I mean C2H, yeah, C2H4, this is ethene. From this, if you remove 2 hydrogen, this will become C2H2. Okay. From ethene, if you remove 2 hydrogen, it will become C2H2. This will become C3H4. This will become C4H6, C5H8, C6H10, C7H12, C8H14, C9H16, and C10H18. These all hydrocarbons you are getting how? By removing 2 hydrogen from corresponding alkene. Okay, from this previous family. Okay, and how we are going to name this? This is, you are going to name is as ethyne, ending with yne. This we are going to name as propyne, pyne. This butyne. This pentyne, hexyne, heptyne, octyne, nonine, and dokine. Okay, all ending with YNE. So this is the homologous series of alkenes. Is that clear? So I have given you a list of 10, and it will go on, right? It doesn't end at 10. I never mean to say that it will end at 10. It will go on, right? So these are some of the examples of the homologous series of alkane, homologous series of alkyl, homologous series of alkene, and homologous series of alkyne. What you have to remember is the general formula of each of the family, how they are connected. From alkane, how you get alkyl, from alkane, how you get alkene, from alkene, how you get alkyne. Okay, these are the things that you should know very well. Another big thing that you should remember is these alkanes will always have carbon-carbon single bond. This will have always single bond. This alkyl, they will always be they will not be stable, because one of the hydrogen is removed from it and its place will be taken by some other element. Suppose methyl, in this methyl group, suppose chlorine comes and get attached over here, then we will call it as methyl chloride, okay, or ethyl bromide. Okay, that way. So anything which is coming and getting attached over here, depending on that what is getting attached, the name of the compound will be formed. But basically it will be called as methyl, ethyl, propyl, etc. So that is alkyl group. Alkene may, you will either be having double bond or you will be having triple bond. Okay, double or a triple bond. These are alkenes. Okay, no, triple bond will be in alkyne. In alkenes you will get only double bond. Okay, in alkenes you will be getting only double bond, right? So in alkane you will be having only single bonds, in alkene you will be having double bond, and in alkyne you will be having triple bonds. These alkene and alkynes, that is double bond and single bond hydrocarbons, are together known as unsaturated hydrocarbons, and this alkane is something which is known as saturated hydrocarbon. I just told you before starting with this, saturated, RATED. Okay, we write it correctly. Saturated hydrocarbon. Okay, so these alkanes are known as saturated hydrocarbons because they are made up of only single bonds, and this unsaturated hydrocarbons consist of alkenes and alkyne, that is double bond and triple bond. So wherever you find double bond or a triple bond, those hydrocarbons will be coming in the category of unsaturated hydrocarbons, and the hydrocarbons in which you will find only single bonds will be coming under the saturated hydrocarbon category. So that was a start of the chemistry session of this IGCSE 10th grade organic chemistry 1. Okay, so once again, before winding up this session, I'll tell you what all things I've covered in this organic chemistry 1. I have covered what is meant by the crude oil. Okay, crude oil is nothing but rich in carbon compounds. Okay, and then I told you what happens to this crude oil. Crude oil, once it is removed, so crude oil is explained. Then I told you what are hydrocarbons. Hydrocarbons are compounds of hydrogen and carbon only. Okay, and these hydrocarbons are you will get these hydrocarbons in various carbon chains, short carbon chains and long carbon chains. Okay, so these hydrocarbons totally in combination will form the crude oil. Okay, this crude oil, when it undergoes something called fractional distillation, this crude oil can be divided into so many fractions. Now these fractions also I have tried to show you. In a fractionating column, the lower portion of the fractionating column will be occupied by the long chain hydrocarbons, and as you go up, the hydrocarbon chain length will reduce. Okay, the upper part of the fractionating column is always cooler and the lower part is always hot. Okay, the boiling point, as you go from top to bottom, the boiling point will be increasing. Okay, so all that we have discussed in fractional distillation. Then what are short chain and what are long chain hydrocarbons, that I have tried to explain you, and I tried to explain you the trend of the properties. So boiling point will increase as you go from shorter carbon length to longer carbon length. Inflammability will be decreasing, viscosity will be increasing, okay, and the short carbon atoms, so short carbon chain hydrocarbons will be gaseous in nature, and as the chain length goes on increasing, it will become liquid and then solid. Then hydrocarbon family I talked about. There's something called saturated hydrocarbon, there's something called unsaturated hydrocarbon. Then homologous series of alkane, alkyl, alkene and alkyl is something that I discussed. And in detail, I made you understand this homologous series of alkane, alkyl, alkene and alkyl. And today's session I'm going to end here. In the next session, I'll be starting with some of the examples of this alkanes. Only alkanes will be taking first, and I'll be discussing the further organic chemistry of this alkanes. So we'll be discussing certain reactions that takes place in alkanes. We'll be studying about the structural formula of this alkanes. We'll be studying about the display formula of the alkanes. We'll be studying something called isomerism, structural isomerism that exists in alkanes. Okay, so all this stepwise we are going to cover in the subsequent videos. Okay, so for today that's all. See you all, take care all of you, and see you in the next video. Bye bye.